Anticipating the next major flood in the United States requires understanding how climate change, land development, and weather patterns interact. Across the country, scientists have identified specific regions on high alert for catastrophic flooding in the coming years. Rising global temperatures increase atmospheric moisture, leading to heavier rainfall events that overwhelm rivers, drainage systems, and urban infrastructure. The Midwest, historically vulnerable to river flooding, faces increased risk as climate change intensifies spring rain and snowmelt events. The Mississippi River Basin, covering 31 states, is particularly susceptible to prolonged flooding from heavy rain across its vast watershed. Warmer winters and earlier snowmelt accelerate runoff into already swollen rivers, increasing the likelihood of record-breaking floods. In 2019, historic flooding along the Missouri River Basin inundated farmland, towns, and infrastructure for months, demonstrating future risks. The upper Midwest, including Minnesota, Wisconsin, and Iowa, is seeing more frequent heavy rain events linked to climate change. These intense downpours exceed the capacity of aging drainage systems, increasing the risk of both flash floods and river flooding. Urban areas across the Midwest face compounding risks as impermeable surfaces prevent rainwater from soaking into the ground. The combination of extreme rainfall and overdeveloped floodplains creates ideal conditions for devastating urban and suburban flooding. The Gulf Coast, from Texas to Florida, also remains on high alert due to rising sea levels and intensifying storms. Hurricanes fueled by warmer ocean temperatures carry more moisture, delivering higher storm surges and inland flooding. Low-lying coastal areas along the Gulf of Mexico are already experiencing sunny day flooding as high tides push further inland. When hurricanes combine with saturated soils and swollen rivers, the resulting floods can submerge entire communities for weeks. The Houston area, already vulnerable to flash floods, faces worsening risks due to rapid urban development and heavier rainfall. Hurricane Harvey in 2017 demonstrated how climate-enhanced storms can deliver catastrophic rainfall far beyond historic averages. As climate change warms the Gulf, future storms are expected to produce even heavier rainfall and longer-lasting floods. Florida's low elevation and extensive coastline make it especially vulnerable to both hurricane storm surge and rainfall-driven flooding. Sea level rise combined with more intense rainfall events increases the risk of chronic flooding in cities like Miami and Tampa. Along the Atlantic seaboard, the Mid-Atlantic region faces rising flood risks driven by sea level rise and more intense storms. Coastal cities like Norfolk, Virginia, already experiencing routine tidal flooding, face growing threats from hurricanes and nor'easters. Inland flooding also poses growing risks to the Appalachian region, where steep terrain channels rainfall into narrow valleys. Intense storms drop large volumes of rain in short periods, overwhelming small streams and triggering deadly flash floods. The Northeast, from Pennsylvania to New England, faces mounting flood risks from both coastal storms and inland rain events. Hurricanes reaching farther north, fueled by warmer Atlantic waters, bring heavy rain and storm surge to vulnerable communities. Inland rivers, including the Susquehanna and Hudson, face higher flood risks from increasingly intense downpours. Urban areas like New York City are enhancing flood defenses, but aging infrastructure struggles to handle more frequent inundation. Extreme rainfall events, once considered rare, now occur regularly across the Northeast, placing millions at risk of flood damage. Western states, despite being known for drought, face increased flood risks from atmospheric rivers and flash flooding. Atmospheric rivers, narrow bands of moisture stretching from the Pacific, can dump immense rainfall on California's coastal ranges. These storms saturate soils, overwhelm reservoirs, and trigger dangerous debris flows in fire-scarred landscapes. The Central Valley of California, already vulnerable to flooding from the Sacramento and San Joaquin rivers, remains on high alert. A warming climate intensifies atmospheric rivers, increasing their moisture content and raising the potential for catastrophic flooding. The potential for a modern-day arc storm, a hypothetical megastorm capable of flooding vast areas of California, looms larger than ever. The Southwest, including Arizona, Nevada, and New Mexico, faces increasing risk of flash floods following extreme heat and drought. Drought-hardened soils are less able to absorb sudden rainfall, sending floodwaters rushing through canyons, washes, and urban areas. Monsoon season in the Southwest is becoming more erratic, with periods of extreme dryness followed by intense cloudbursts. Urban sprawl in cities like Phoenix and Las Vegas amplifies flood risk, as paved surfaces accelerate runoff into streets and homes. The Pacific Northwest faces complex flood risks driven by heavy winter rains, rapid snowmelt, and shifting storm patterns. Warmer winters increase the likelihood of rain falling on snow, triggering rapid runoff and flooding in mountain watersheds. Rivers like the Willamette and Columbia face greater flood potential from both heavy rain and melting snowpacks. Coastal communities in Washington and Oregon face additional risks from rising seas and more powerful Pacific storms. Alaska, often overlooked in flood risk assessments, faces new challenges as melting permafrost destabilizes riverbanks and triggers erosion. Increased glacial melt adds more water to rivers, raising flood risks in communities near retreating glaciers. Indigenous villages along Alaska's rivers face relocation pressures as flood risks grow in tandem with climate change impacts. Flood risk mapping across the U.S. is being updated to reflect new climate projections, but many communities remain underprepared. Outdated floodplain maps fail to account for climate-driven shifts in storm intensity, leaving residents unaware of growing risks. Infrastructure designed for 20th century rainfall patterns is increasingly overwhelmed by 21st century climate-enhanced storms. Stormwater systems, levees, and floodwalls built for historic flood levels now face water volumes far exceeding design capacity. Federal flood insurance programs struggle to keep pace with rising claims as flooding becomes more frequent and severe. Homeowners in newly flood-prone areas face soaring insurance costs or lose access to affordable coverage altogether. Disadvantaged communities, often located in lower-lying floodplains, face higher flood exposure with fewer resources to recover. Emergency management agencies increasingly emphasize proactive flood resilience strategies instead of reactive disaster response. These strategies include nature-based solutions like wetland restoration, floodplain reconnection, and green infrastructure investments. Expanding flood warning systems, improving evacuation routes, and updating building codes also play key roles in future flood resilience. Anticipating the next major flood requires combining historical data with emerging climate models and real-time environmental monitoring. Satellite imagery, river gauges, and atmospheric sensors provide crucial early warning data to predict flood risk across vulnerable regions. However, predicting exactly where and when the next catastrophic flood will strike remains challenging in a rapidly changing climate. What is clear is that every U.S. region, from coastal cities to inland farms, faces rising flood threats in the decades ahead. The next major flood may not only be bigger than past disasters, it may strike in unexpected places at unexpected times. In a warming world, the only certainty is that floods will come faster, higher, and more often than history would suggest. Communities that anticipate these shifts and prepare today will be better equipped to withstand the floods of tomorrow.